This week, we are going to focus on a specific topic of kind of GPU transcoding, GPU mining, what that means in Streamflow, what the opportunity is. And I'd actually kind of like to have an open discussion with a lot of people who have joined the call who may be infrastructure operators, GPU miners, to get kind of their feedback, their ideas, ask questions around a few topics that are going to be relevant to everyone. So thanks for joining. Nelson is one of our great kind of community members, community leads, who has done a lot of the coordination with people who said they're interested in joining. Nelson, is there anything you'd kind of like to add, or anyone you'd like to introduce as part of the call before we jump in and start the discussion?
Hey guys, yeah, Nelson here. No, look, I think everyone sort of had a brief chance to introduce themselves, but if anyone didn't, it'd be great to hear from those people. But otherwise, I think it'd be great to just jump straight into the discussion.
Just briefly, Mark Blair. I joined the LivePeer team, focused on helping them move things forward. So good to be on the first call. So I'll be silent now.
Good to have you, Mark. You're welcome to participate and dive in anytime you have questions or comments, as is anyone. And also, by the way, that goes for anyone on the LivePeer team. We're going to be talking about GPU transcoding and mining, and there's a bunch of members on the team where that's a subject that's near and dear to their hearts. I know Michael, Josh, Philip, and more as well. So looking forward to participation from everyone. Okay, so for today's topic, I'm going to kind of share a brief presentation just for the beginning, but then I'll jump out of the presentation and kind of into more open discussion. Can someone give me the thumbs up that they can see this presentation that says GPU transcoding? Good.
We can see it.
Okay, looks like yes. Excellent. We're good to go. Okay, so for today's agenda, I'd like to do a quick summary and run through of the opportunity that is created through LivePeer around GPU transcoding and video mining. And then I'd like to get a kind of update on the current development status, maybe some of the high-level details on some of the benchmarking and bottlenecks that we have, though it's still early in some stages. And then really jump into discussion where we talk about some of the topics that are going to be important for people who want to run as transcoders on the network post Streamflow. So that looks like talking about bandwidth. It looks like talking about mining software, and even starting to get into people's interest and willingness to kind of customize their setups, customize their software themselves, just to get some feedback in terms of what would really be valuable for, let's say, the LivePeer core team to deliver to the community versus what the community likes to kind of customize and run with themselves. So that'll be a good discussion later, and of course time for open Q&A. Okay, so just to briefly summarize the opportunity. This is not something new. This is something we've published blog posts about and talked about on previous calls, but just to run through it really quick. So what we're looking at here is an NVIDIA GPU, right? And you see a bunch of different components on there and even some specifications of the features for video encoding and decoding. So many crypto miners are running NVIDIA or AMD GPUs that look similar to this. And what most of them are doing in the kind of cryptocurrency mining space is they're using those CUDA cores, those kind of 100 little boxes at the bottom, in order to hash cryptocurrencies. And if they're running these at 100% capacity, here in the US with current electricity prices, they basically want to earn about $1.50 in cryptocurrency per day in order to break even on their kind of electricity and OpEx cost for their card. That number might not be perfect. It might depend on your cost and whatnot, but it's just a rough ballpark. So the opportunity is that there's these ASIC chips, these video decoding and encoding chips that are kind of circled in that red box that are sitting completely idle on these cards. They're not hashing cryptocurrencies. All they can do is encode and decode video. And they have the capacity to transcode kind of 2 HD videos at the same time on kind of the previous generation of these cards, and into kind of your standard adaptive bitrate output encoding. And the kind of rough cost for doing so is about 14 cents in electricity and 60 cents in bandwidth per day. That bandwidth number, it's something we're going to discuss later because it's highly dependent on kind of your location and your pricing and availability. But what you're seeing is about 74 cents per day is the cost to someone with a GPU to do this encoding. And then here's the really powerful kind of market opportunity and number is that cloud providers who, video applications and broadcasters pay to do transcoding are charging way more than that 74 cents per day. They're charging $144 per day to transcode 2 HD live stream videos. And of course, they're doing more than just providing the raw hardware. They're providing a nice product, interfaces, redundancies, failovers, kind of guaranteed performance. So a lot of what you're paying for is more than just the hardware. But still, if you look at a network like LivePeer that lets people with these GPUs compete to, do this encoding work, and if the LivePeer protocol and software can, give enough reliability, can route this work accordingly, can prove it's done correctly, then there's a huge gap between the 74 cents it costs you to kind of run this hardware at full capacity and the $144 that cloud providers might be charging a customer to do that. So it gives you as crypto miners the opportunity to charge any price higher than 74 cents to make additional revenue. And the idea is to do this without disrupting or being minimally disruptive to your existing cryptocurrency mining. So you don't need to necessarily choose either or give up the ability to continue hashing. You should be able to encode video when it's available, and when it's not available, continue to hash, and ideally maybe even do both at the exact same time with some level of efficiency. So that's the summary of the kind of big opportunity. That's what we're trying to unlock in LivePeer, and hopefully it's familiar to everyone. We have a blog post about it called the video miner opportunity, and if you Google that, you'll find that. So that's kind of the summary of the opportunity that we're trying to unlock. In the kind of early version of LivePeer that's live right now, the alpha version, the software doesn't support GPU mining. But in the kind of recent versions that have been, can be kind of built and compiled from GitHub, can be tested, we now do support GPU mining or GPU transcoding as of recently. And I'd like to kind of jump into a development update on the progress there, but I'll kind of jump out of the presentation here. So maybe, Eric, I don't know if you want to kind of jump in and give the current development update and talk a little bit about some of the benchmarks and whatnot as well.
Yeah, maybe I can just give an update about like the few different areas that we're working on in enabling GPU for the LivePeer network. So one thing that we've been working on for a while is to just get GPUs to run at all using like just being able to access the GPU transcoding chips if there's a GPU available on a machine, right? So that we'll be working on that, kind of doing the integration with the low-level drivers and the libraries that will enable GPU transcoding, and that should bring about 4x of acceleration to the current transcoding CPU trend. So that's been done. Another thing that we've been working on. Sorry, let me just. Another thing that we've been working on is to enable GPU transcoding on a actual mining server, because these mining servers have a very different architecture from a regular computer. right? They usually have many GPUs, up to 10. I've seen up to 10 GPUs running on the same machine, and they usually have pretty minimal components for all the other components on these machines. So we've been working with like cloud mining providers or just mining facilities in general to make sure our software actually runs on these hardware architectures well. And there we've been making progress, but we're not completely there just yet. We still have some bottlenecks when it comes to being able to take advantage of many GPUs on the same box. So right now, I think we go up to like six GPUs on a box, and then if it gets more than 6, then the performance like we don't get any performance in improvement, and that's kind of comes from like how the software works today and the overhead of setting up the GPU sessions on these hardware. But we're working on software solutions to address that problem. Another thing, so that's just enabling the software to run on a mining hardware with multiple GPUs. And another thing that we're working on is to be able to run the mining software alongside of the GPU transcoding, which is another, it's kind of like one step beyond that. And there, we've done some very early benchmarking by just running the software, mining software, and running some transcoding side by side, but we have not really done the integration to make sure both running very efficiently just yet. So that and that's something that we kind of have some theories currently, but we would love to start exploring a lot more. So for example, one of the theories that we have is that we actually, instead of being able to run just off the shelf mining software alongside of the LivePeer node, we might have to just run one piece of software to like actually fork the miner, so that the LivePeer process itself has better control of how the resource allocation is done. These are things like having one single process accessing the GPU driver at once instead of multiple processes, because that's not allowed. But these like software architecture decisions are still kind of like being made right now. So that's kind of an overview of what we have been working on. But Josh, I don't know if you have any other thoughts to add here. Let me see. I'm trying to enable Josh, but it looks like the interpreters the interpreter is muted. Can anyone unmute the interpreter? Maybe the interpreter just muted right now by default. Okay. So let's not worry about that. Let's just. I'm gonna kick it to Doug. Maybe we can open up a discussion about GPU transcoding.
Sure. So thanks for the update, Eric. It sounds like, if I were to summarize at a high level, like right now the software supports GPU transcoding, and if you kind of are running a single GPU setup and you have a single machine that's acting as an orchestrator and you have a single GPU transcoding behind it, things work pretty well, and we have sub-real-time transcoding, and that's almost ready to go. But when it gets to actually scaling your setup and taking advantage of many GPUs, that's where we're trying to basically improve the efficiency. Or are we actually running into some blockers where that's actually working slower than real time or not necessarily able to be supported yet?
Yeah.
Okay, great. And so I know there's some benchmark work that's being done that actually has some real numbers in terms of number of seconds to transcode your standard adaptive bitrate ladder. And I think those are numbers that I guess you and Josh can share and publish as we have like clear understanding of what they mean. We've worked through removing some bottlenecks, and we can actually put them out there for people.
Yeah, I mean, we've seen numbers going all the way up to 10x faster than real time when it's running on multiple GPUs. But I think those numbers can actually be a lot higher, and we're after we resolve some of these bottlenecks.
So we
Cool.
already, in the presentation that Doug just showed, we estimated with 2 streams per channel, but our benchmarks on current state-of-the-art GPUs like the NVIDIA 1080 Ti card is more going in the direction of 8 to 10 concurrent streams. So GPUs also become more and more efficient over time.
Those people were all in the wrong Hangout.
Got it.
Sorry that there was a confusing Hangout link. Welcome to the call. We covered an update on kind of GPU mining opportunity and the current development update. And we're just about to kind of start a discussion on topics that are going to affect people who want to actually do GPU transcoding on the LivePeer network. So I think the 3 kind of topics that I had were, one was talking about bandwidth and how that comes into play for a current GPU miner. One is talking about mining software and maybe getting some feedback on willingness to run existing mining software side by side with LivePeer software, to modify existing software. And then finally, just some feedback on people's setups and how they're thinking about kind of dedicating resources to LivePeer versus trying to do resources that are dedicated to both LivePeer and mining. Might be helpful to us as well. So let's talk a little bit about bandwidth. So this is the one area that is kind of a newer requirement or consideration for people who are currently mining cryptocurrencies, where the amount of bandwidth that you have may be not necessarily kind of a critical feature or bottleneck. You can get by with producing blocks for crypto networks without a tremendous amount of bandwidth. But if you want to transcode HD video and you want to serve the outputs for many of these videos at once, all of a sudden you do have bandwidth requirements. And so how much bandwidth are we talking about, and what sort of price does this bandwidth come with, and do you already have more than enough bandwidth, or does this become a new cost for you, are kind of the relevant issues. So I think I'll try and give a summary. People can jump in and correct me if they have sort of different information. But when I think of kind of your standard transcoding job for kind of user-generated content and one-to-many broadcast, you're looking at potentially an HD video being captured, so like a 1080p video, and you're looking at 3 or 4 different, we're getting a phone call, I don't know where that's coming from, and you're looking at 3 or 4 different output bit rates, like 720p all the way down to 240p, so it can be played on all different devices. And so typically you're looking at kind of minimum 5 megabits per second in order to upload these renditions. Oftentimes it's double that, about 10 megabits per second. And so for each stream that you want to encode concurrently, you may need to be able to access an additional 10 megabits per second of bandwidth, right? And oftentimes, on people's home connections, you see, especially I'm speaking like here in New York City, where bandwidth is pretty prevalent. It may not be the case everywhere, but a lot of times people have 100 megabit home connections or even gigabit home connections, business connections. They may be paying for the same, but when you're in a data center, it's priced a little bit differently. And ideally, hopefully, you're able to acquire bandwidth at scale for approximately ballpark $1 or a couple of dollars per megabit per second per month. So if you have 100 megabit per second plan, you're paying $100 a month, you can probably always be concurrently transcoding 10 HD streams of video on the LivePeer network, and that can be factored into your price accordingly. But as we know, all mining operations around the world may not be in locations that kind of have access to this high bandwidth at low prices. So what we think about is on the LivePeer network, it's an open marketplace. There is competition, and people who have these efficient setups who can access this bandwidth efficiently will just be able to compete and charge a lower price and win work versus people who may not have access to. But at the same time, kind of your proximity to streams also matters. And so if bandwidth's more expensive in a specific location, but that's where the origins of the streams are, well, the users there may need to kind of pay that market price in order to cover the costs. So it's kind of a quick overview of how bandwidth comes into play and it works. I guess I would kind of open it up for questions or discussions or additional thoughts that people have who may be kind of running infrastructure right now. Do you feel that you already have and are paying for access to significant bandwidth that can be put to use for LivePeer? Or do you think this is going to be a new challenge for you? And do you think it's an addressable, tackleable challenge? Who wants to chime on this? What about some of the kind of more scaled infrastructure operators? I know there's a bunch of people on the call from Blockdaemon. Do you have any perspective on how much bandwidth you currently have access to, and whether this becomes a new consideration or something that's kind of minor?
Yeah, this is Nye from Blockdaemon. I will definitely say bandwidth is always a challenge. Obviously anything on site, on-prem, somebody in a home, small office, big office, they're already at some more bandwidth crunch. If you're in a cloud, it can get very expensive very quickly if you're pushing or pulling a lot of bandwidth. So that kind of the economies of scale kind of break down because it doesn't really help you too much. At some point, you just end up. I'm just basically at that point subleasing or equipment I'm already paying for. I think maybe the only place that might actually work is in a data center, which has an also very, very large cost, but you might be able to make that work a little bit better as far as when you get into the 1 gig or the 10 gig. The bigger problem is that even in the data center, and the pricing is, they're generally, the sweet spot is the burstable pricing, right? And for what we're looking at here, we're not talking about we're not talking burst. We're talking like presumably long sustained connections. And at that point, you're looking at basically CDN pricing. And that's a whole nother ballpark, and that sends you into the stratosphere as far as pricing goes. So that's
crazy, because usually CDN pricing is a lot cheaper than origin pricing in data centers. Like in Amazon, you still pay like nearly 8 cents per gigabyte for delivery, which is kind of expensive. But if you go to a big CDN and have a lot of traffic, then you are under a cent in the meantime. Anyhow, it's definitely true that like if you need dedicated resources on the task, there's definitely a big additional cost. If you have access capacities on bandwidth, then you can contribute accordingly, right?
Well, this is Rick from Blockdaemon. Our data center has 20 gigabits per second in and out, I believe, but I don't know what we're paying for that.
Yeah, I can kind of speak a little bit to that. It's a burstable, so we're 1 gig and then 10, 20 gig big. Well, it's 2 1s and then 2 10 gig burstables. So if we're at the 1 gigabit, it's fine. If we're at the 1 gigabit sustained, it's not that big of a deal. But if we go over that sustained, it will go up. I don't know the pricing off the top of my head, but I do know at that point CDN pricing becomes more attractive. Now I'm not sure whether we can get. I don't know if there's a combination of us getting GPUs into CDNs. So I mean that's the other issue that I don't have any experience with. I mean the clouds are only starting to get GPU support into their clouds even. So if you look at I guess I just saw an announcement yesterday from Linode. They're launching some GPU stuff, but you're paying Linode. Presumably, you're going to be paying Linode bandwidth pricing, which is not competitive with CDN pricing, as I guess the other caller pointed out.
Yeah, we had when I worked at HBO, we had everything was CDN, but the content was pre-transcoded and then it was shipped to the CDN, and the price break was the output to the CDN was the full price, but you only pay that once, and then the CDN distributed that content to all of its endpoints, and then when people streamed at their home watching Game of Thrones, it was it was low, much lower price.
Yeah, but that's the one-to-many
That's
CDN.
for on demand.
Yeah, and that's the one-to-many CDN model, right? That's like I'm broadcasting a single stream to multiple people. It's not like a completely peer-to-peer bandwidth model, which is the other issue.
Some of LivePeer is.
Well, in LivePeer, actually, it is more similar to that CDN case, actually, because right now what we're talking about is bandwidth constraints only for the initial transcode and upload of the output transcode renditions. We're actually not talking about peer-to-peer content delivery, right? So the constraint is how many streams as a transcoder do you want to concurrently have capacity to encode, and you kind of make that decision as you see demand grow in the network, and if you have excess capacity to transcode, it's profitable and you can charge a price that kind of covers that encoding and bandwidth cost, then you get to kind of make that decision yourself. But no, you don't need to take into account actually delivering content to the end users. That would likely be performed by whatever the application's delivery choices, whether that's a CDN or peer-to-peer delivery on their own side. That would not affect you as an infrastructure operator on LivePeer.
Right.
Okay.
So the inbound costs are minimal because that's the CDN model, and the outbound is, number one, it's already transcoded, and you're saying that I'm not going to be sending a bunch of large streams. Well, but it's still per node that you run, though. Each of those is going to be running a different output stream.
Yes, you will have origin traffic, but you won't have edge traffic. There will never be a connectivity of a consuming user, but you would have that bandwidth utilization per stream that you encode, of course, because the source has to get in and the encoded outputs have to go out, right?
But you're saying the out is going to be a multicast stream. It's going to be distributed to all the other peers or anybody else that's interested.
No, we don't do multicast. It's only unicast. It's an HTTP delivery basically of the segments.
No, but that's what I'm saying. That's in CDNs. That's where you get my understanding is that's where you get the bandwidth cost break, is because you're multicasting. So you're not paying individually for end streams. You're just paying for the initial stream that's multicast. Whereas if I'm going to distribute a bunch of streams to a bunch of different endpoints, they're all charged as separate streams.
So multicast doesn't really exist on wide area networks, as routers wouldn't allow multicast traffic because it would hit all routers on the internet, right?
I'm not saying literally multicast. I'm talking about the higher level protocol multicast. So when you're distributing in a CDN, if you're distributing the same content to multiple users, you have some sort of fan out, right?
Okay. Yeah.
Maybe
infrastructure. Yeah, you could put caching infrastructures behind it. So the transcoder in our case would most likely stream into an object store like S3 or something, right? And it would only do this once per stream it encodes. It wouldn't do it multiple times. So
Understood.
There's a straight calculation for bandwidth per stream that you do.
Okay, so
Yeah, maybe the distinction here is the difference, like what's the responsibility of transcoder that's running the infrastructure, right? So here what we're saying is that the responsibility of the transcoder is not to also deliver to every single viewer. It's simply just to deliver the transcoding result back to the application requiring the transcoding job to be done. And then for the delivery, the application is going to figure out how to get that delivered to all the viewers that they have.
I mean, this should work seamlessly in current existing video workflows and video platforms that already have infrastructure for that available. And what they seek is reducing the overhead cost of owning or running that infrastructure And by being able to outsource it to a third party, they can achieve this. But they have their own caching infrastructure, they have their own storage, and for the transcoder,
Did we lose you, Philip?
sorry, my son came in. 1 second.
Okay, I was
Alright,
gonna say
well-
sorry for my ignorance, but I think my question was answered. So LivePeer is just the transcoding jobs, and if I'm a user who wants to use LivePeer, I'm responsible for distributing the video after LivePeer gives me back the transcodes. Cool.
Yep. So
At
again, I
at the
think
moment, we do have some options to maybe make that a little bit easier. Like like Eric mentioned, the transcoder itself is not responsible for the for the delivery. But what the consumer can do, or the broadcaster can do, is give it information to use the cloud storage, like Amazon S3. And then the transcoder will upload the results straight to them or to your bucket. And then you can serve it or have a CDN hit that. So it's a little fewer steps in the process.
great. Okay, so I'm just
Okay, cool.
looking at time too, and I guess summarize a couple of the takeaways on the bandwidth discussion. Is just bandwidth is kind of purchased up front as a kind of no max limit, and as node operators are making the decision about how much bandwidth they have available or would like to add to their LivePeer network, they can probably do some sort of calculation where each 10 megabits per second per month that you add, which may cost you $1 to $5 depending on where you are, maybe less in some locations, enables you to encode an additional stream concurrently. And you'll probably want to see how much demand there is on the network, how much work you're possibly winning in order to make that calculation. If you have a setup where you can add and remove this bandwidth, you may have an advantage. And if you happen to have more bandwidth than you're using already that you can put to use here, then you have an advantage. And if you are in a location where it's really expensive and you need a really long-term contract for a high amount, and that sits idle because there's not enough work that you're winning, then you may have some inefficiencies relative to the rest of the network. So I think that's some interesting takeaways on the bandwidth side. Cool. So the next topic I wanted to just jump into a little bit was so kind of this concept of dual mining and this notion of mining cryptos concurrently with transcoding LivePeer and what that looks like. So this is the holy grail, and the opportunity is that these resources are utilized side by side concurrently at the same exact time. But as we're iterating towards that, there's a number of different possible solutions that can be put into place so that you can do both, maybe not at the exact same time, but you can kind of fall over from one to the other when the more high value job is available. And so these are the types of things that we're thinking about, we're iterating on, we're doing kind of proofs of concept and reference implementations on. But I kind of wanted to open up a discussion and get some feedback on the concepts here. So Michael's on the call. I know you have some thoughts around kind of some of the open source mining software that exists and the opportunity to, and the reasons for potentially, modifying that to build my peer support and the ability to potentially run that side by side with others. So maybe you want to kind of share your view of the world, and kind of we can open it up to other Acker discussion as well.
If we want to have any sense of concurrency or even time slicing, we're going to need to take an open source miner and add support for LivePeer to that software. What I think would make the most sense is to prioritize the video transcoding, and in parts of the system that are idle, the miner will instruct it to do some mining. I don't think that there really are many other options other than just doing video transcoding alone. The reality is, if you're going to mine and transcode together, there's going to be kind of a dance that needs to be done as far as who owns the memory and who owns access to the device. So, I think we'll probably start with something like ETH miner is my guess, because Ethereum is something that makes sense to start with. But all these things are really just in discussion right now. Nothing's been finalized, and some people disagree even with what I had just said just now. I feel pretty sure of it. But we're a bunch of engineers, and everyone has different ideas. So we have to prove things out and see where things go.
Yeah, I'm interested in hearing some of the feedback from our miners on the call, in terms of is there any requirements, or just from the miners' perspective, what would be what would be some of the constraints? Is it is it important to kind of run a piece of software that's published by open source software, the original miner, or is it not a big deal if it's running a LivePeer version, or is it okay if the LivePeer process is actually doing the mining but also transcoding? What's kind of is there any preference?
If I just may interject, I just want to say most of the miners out there are forks of other miners. So Ethereum is one unique one where ETHash itself hasn't changed much until now, while they're integrating ProgPow. But anyhow, let's see what anyone else has to say about it.
One question I would have, because I haven't looked at the code, is it possible to access the NVIDIA GPU from two different processes? Because if that's possible, then the LivePeer could just access the encoder-decoder parts and wouldn't even have to modify a current miner. It would just be a separate process, but I have to go look at their APIs. Have you guys looked at that?
Yeah, that's definitely possible. Otherwise, usual stuff like gaming and streaming wouldn't work, right? As soon as the game would load a video decoding on the GPU, everything would fall apart. So yeah, that's definitely possible. It's more about resource allocation. And here we have the problem that any typical mining software that you find is optimized to utilize the most out of the card. And if you go to specialized mining rigs, you even see that the drivers were they basically tweaked the drivers. They tried to disable everything in there that would take electricity without contributing to the hashing, and they tried to max out the available CUDA cores to get to a good hash rate. Now, what we have to do is basically to make both work side by side with doing a clever resource allocation. We have to secure enough memory, enough resources in the card for the video transcoding, and still have enough there so that a specific hashing algorithm would work, most likely with a lower hash rate then.
Philip, I agree with everything you said, except for the part where you said it would definitely be possible for multiple processes to own the video card. Now, when we say process, we're talking about an executable running on the operating system. And I don't see any evidence that multiple executable processes that are not related will be able to run and control one single piece of hardware concurrently. If it is possible, that's great news. But do you know this to be true?
Yeah, absolutely. Otherwise, we couldn't use multiple FFmpeg, multiple versions of FFmpeg at the same time on the same GPU, right?
They're all
You can
linked
do
into
that.
the same process.
You can run FFmpeg
It's one
twice,
process.
but the different
Dr. I believe that you may be there may be some limitations to how many CODA cord processes run on the GPU in terms of how they are scheduled. So that may not be able to run in concurrence. But I believe that you can still have it there, and then the driver would schedule them sequentially. As I have run several processes encoding on the same GPU, and that's a little bit different, but it is a different process. And we use the CODA secure scaler in real time beside the video. It's possible that the GPU sees that in the same application. It's the same GPU application, the same CUDA application. But it's something that we need to test more, definitely, soon.
Well, also the resource allocation thing kind of answers my question too, because you wouldn't want to run an unmodified ETH miner or ETH hash because it would shut off stuff that we want. So that makes sense too.
The goal is to find the sweet spot where both can live side by side without making the whole system unstable.
And that's another interesting point, because a lot of miners try to run pretty lean on the actual hardware except for the GPUs. So, you know, low spec CPUs, like as little memory as possible with just enough to get the GPUs running and hashing performantly. So I guess, is there any other considerations, the hardware platform? Because a lot of people will just run, they may be specialized motherboards, but they may not have enough PCI bandwidth to support multiple cards at once.
Yeah, absolutely. So the biggest concern was that the big amounts of data wouldn't fit through these riser USB adapters that they use to strip in multiple GPUs to without PCI Express, right?
Yeah.
So, but that's not really an issue, because what we do is we send in compressed video into the card, and that's really just taking the few megabits that you also receive over the internet, right? It's the same amount of data that we give to the card, and there it gets decoded and blown up, and then it's becoming really big, but it's not leaving the card before it's compressed again. So in the end, you know, one of these riser adapters could easily handle 12 to 20 streams, and each taking 10 megabits.
Interesting.
Because it's USB speeds, right?
Mm-hmm.
You see?
That had a CPU performance bottleneck then as well. And
so, yeah, we try to keep the logic that happens on the CPU down to basic file routing. It should not do complicated tasks. It never touches really the video, right? It's there to receive job information, hand it over to the GPU, take the input, push it to the GPU, take the output, and push it back to the source. And that's more of a job of a router. So even my dual core Intel did it well here.
Yeah, so there's like the resource allocation on the kind of hardware itself in order to get the max performance, but there's also kind of the economic maximization calculation that people are going to be doing. And if you look at the realities of the numbers and the prices that people traditionally pay for video transcoding, it seems to kind of dwarf the amount that is earned, per minute, per hour through cryptocurrency mining. And so, at least if we look at kind of the short term as, maybe only reference implementations exist or kind of less efficient kind of dual mining software exists to take maximum advantage of the underlying hardware, you still see this tremendous kind of economic advantage of doing the video encoding still at a price disruptive price when that's available, and only kind of backfilling with the cryptocurrency mining when there's no video transcoding available, and that still should create a higher revenue stream for the users as long as there's demand, as long as there's video thrown through the platform. So I think that's clearly like the first goal and focus of kind of a reference implementation that we put out there, is just to ensure that you can do the transcoding when it's available and charge a price that creates kind of a better economic output for people with these GPUs, as long as they do have the bandwidth and kind of enough capacity to do the work. So yeah, I think that's and then how we can optimize that, how we can fork existing miners and modify them and kind of integrate with LivePeer. That's work that we can do over time. But it's also interesting to think about, the community and the existing miners maybe doing some of that work as they see the opportunity available. And I'm not sure whether that leads to, open source implementations that are highly available that everyone can run, or more individual closed source proprietary implementations that people are using to compete and be the most efficient orchestrator transcoder set up on the network, or release it under some of the kind of I don't know the name for the model, but I guess the model where if you run this software, then a portion of the rewards that you earn go back to the author of the software. So there's opportunities on that side as well, and that'll be interesting to see over time. Cool. So I guess one last question I had, just to get a sense of feedback. Right now, everyone who's operating on LivePeer is they're running dedicated resources for LivePeer because they have one of these limited slots on the network as a transcoder. They're earning inflationary LivePeer token, and for the next 2 years, that kind of inflationary LivePeer token will still kind of be high as it comes down and finds its equilibrium. And so one thing I'm wondering about is, are people, maybe just a show of hands, or you can add in the chat or chime in with thoughts, are people here actually trying to, immediately jump in and take advantage of this dual mining opportunity, and that's what's really attractive? Or are you thinking more about actually dedicating hardware to LivePeer in the short term, just because it's maybe easier to operate, works out of the box, and you kind of want one of those orchestrator slots on the network and kind of earn inflationary token on the network prior to there being a lot of video? It would just be helpful to get a little bit of feedback on that.
I know we're going to be getting hardware for an orchestrator separately, but we're not really a mining company. We're an infrastructure company.
Right.
Andrew.
So, yeah. So you guys see the opportunity to be an infrastructure provider, to be an orchestrator on the network, to earn LivePeer token, increase the value of that LivePeer token, and if you can support the network by doing work and earning fees at a break-even price or something, that's interesting to you.
Andrew, you're a miner.
Yeah, I have a couple of rigs. Any extra revenue is ideal. I like the idea. I like the model. It'd be interesting to see how it all comes together. But from a business sense, yeah, I guess there is an opportunity there to, if you've got hardware that's doing one job and you've got extra capacity, why not utilize it and get paid for it?
Yeah,
Andrew, what would it take us to give you, or to release to you, to to get you to, try this out? Would you need one piece of software that handles both, or would you try and figure out how to kind of customize the resource allocation to run a live peer alongside of your existing processes?
I guess the easiest option is the best, but miners, we like to tinker with things. We like to play around and try and optimize and squeeze everything we can out of the machines. Again, purely from a configuration perspective and a trial and error, but from the like, if I was, sorry, just to reiterate the question there, you were wondering if it was possible, like what would it take to get the 2 pieces of, which would be ideal for a miner? Is that what the question was?
Well, I know that what would be ideal is they can just double click one executable and all of a sudden they make more money, right? So that's the ultimate target. But just in terms of your personal interest and willingness to explore, to tinker, to get this set up, I guess I would just ask how far you're willing to go. Like, are you willing to write custom code in order to get this working? Are you willing to play around with configurations of resource parameters in your system?
Well, certainly from the configuration side of things, when it comes to mining software, as in the actual implementation of it, I will say I have very little experience there, but I have a lot of experience of using lots of different softwares, different miners, and figuring out the quirks and the tuning options with them. And that's, that's an interesting path when you have the time to do it. Yeah.
Right. Yeah, good feedback. Thank you.
But there are miners out there that are like, they dive into that stuff all day. They live in there. They're modding BIOSes and doing all these things to squeeze as much as they can out.
Does anyone have feedback about what they think would happen if we put out, say, a reference implementation that did this at some level of efficiency? Do you think it's likely that we would see open source software that would improve upon that? Or do you think that what gets built would remain kind of closed source and proprietary in order to get competitive advantage within the miners that do the work?
I'll chime in there again. I know from a lot of miner conversations in different chats and groups, a lot of them are very skeptical of closed source things initially because someone could put anything in there that could change the wallet address that you mine to or something like that. So people do like transparency. But then you end up with everyone forking it and doing 100 million versions of the same thing and adding founder rewards and all these things, So yeah, I think you see a bit of both. But I guess from my perspective, if there was a distribution by say yourselves that was, here's the live peer miner that also does Ethash or also does some other algorithm, I think people would be open to that. Especially if they see that there's rewards in it for them.
Yep.
Yeah, when I was trying to do Ethereum mining, I had like 6 GPUs and I was doing the whole trying to get the Ubuntu distribution to work. And it was so much trouble, I finally bought EthOS, which is a small, I guess it's more for professional miners, but they had a very open support structure. So it wasn't like, I'm buying something completely closed source. I knew who these guys were.
There are
my experience.
There's 2 other popular solutions too, Hive OS and SMOS.
Yeah, definitely. If you could get a distribution on there, then you will definitely get people that will just, it's kind of like point and click,
I know. I also was testing with Ethos when I was creating my own mining rig, and yeah, the problem really was that we had to strip it all off because it was literally taking all out we needed to make video work, and a plain Ubuntu gave us a better result in the end, or a quicker result. But yeah, it's definitely worth exploring how we could fit into them.
Yeah, because I guess a lot of large-scale miners would use software like that to manage multiple rigs at once from a single place. And you can push out all your updates and all your changes directly from the user console, which is...
Well, I know the guy that created EthOS, and he is like a GPU mastermind, like even reflowing the solders by putting it in an oven or something. And I do know that he tuned that to be specifically for the mining. So in that particular OS, I'm sure you couldn't get anything else out of the GPU.
Yeah, absolutely. The driver stripped out everything that would even touch the NVENC encoder and decoder. So, but yeah, they could add it, or we could add it and contribute there. But I think Ethos is that one isn't open source, right? That's a paid version. It's only like $30 or so. But
Yeah, that one was buy it, but it was buy it and it just worked. So I don't know. I mean, I could reach out to the guys. They're here in New York State that do that, and you know, maybe they might be interested, adding more value.
Actually,
I'm sorry?
this would be really helpful. It would allow us to look at the differences in the data set, what they require to get their thing on a good performance, and what they strip out from us. That would be a necessity. So if you could get us together with them, would be great.
When it comes to integration with Hive and SMOS, I have contacts for that as well. Hive has accepted my own pull requests. SMOS, I have a contact that has done minor integrations. All we'll have to do for that case is static linkage, and the drivers are already the compute drivers.
All right, this is great stuff, and this is kind of exactly what this type of call is for, to kind of get everyone talking and push these ideas forward and everything. I'm looking at the time; it's the top of the hour, so I know many people here may have to move on to their next things. So I'm happy to kind of stick around for a few more minutes if people want to carry on the discussion. But I would take this opportunity to thank everyone for joining. We've been recording it, so we're going to capture this and put this online, and we'll be back in 2 weeks for the next call. So if anyone wants to stick around and keep talking, I'm here for a few, but otherwise, thank you very much, everyone.
Thank you. Bye.
Thank you.
Thanks. Cool. Doug, are you in New York City?
Yes, I am.
We should get together.
Absolutely.
I'm in Brooklyn.
Yeah,
All right.
that's where I live. So yeah, let's follow up and we'll find a time.
Cool. But maybe not this weekend when it's 111-degree heat index.
We'll let it cool down.
That's all right.
Anyone else on the call that didn't chime in and had any questions we didn't get to, or any other topics?
No.
Hey Doug, just one quick question here. I think someone alluded to earlier. Most GPU miners run like very stripped down hardware other than the GPUs themselves. So would it be possible for you guys to maybe when you put out a reference implementation of the software, to also perhaps give some recommended hardware configuration in terms of hard disk space, memory, and CPU? So those of us who have mining rigs can consider kind of upping the configuration to kind of be able to do transcoding as well.
Yeah, definitely. I think we should put out kind of benchmarks that include the specific hardware configurations that we've used and resource allocations we've used to create those outputs, and then make a recommendation. But hopefully from that data, you can make your own decisions about what it's worth investing in. You can look at how much demand there is on the network now and make estimates for the future, and make your own calculations off kind of the base recommendations.
Great. Yeah, the only other question I have is how far do you guys think, how far out are you from kind of putting something out there that GPU miners can start testing?
Good.
Eric, what do you
question.
think of that?
So technically everything is open source, so people can go get the code and compile themselves and start running it and testing it locally, because for the single GPU case, it is working well. But realistically, if we think about some kind of packaged software that's that's ready to be just run and with a command line, and you can see the video transcoding output. We think it's like I would give it a month or so to like really for us to really work out the kinks. That would be my current estimate. But knowing how software development goes, I cannot give a very firm answer.
I could add that the code required is already merged into the master branch of every repository involved, as far as I'm aware, right? So it's just a matter of figuring out how to build it, and putting together easy documentation to follow is one of the things that we're working on right now.
Right. Cool. And I see in the chat that there are some questions about VOD transcoding and our SRT usage. Very interesting topics and near and dear to our hearts. VOD transcoding is something that we've been thinking about for a while, but haven't really spent too much time exploring, just because we've been focused on the live use case and because the cost of transcoding for live is so much more so much bigger when it compares to the cost for VOD, right? For VOD, we've been thinking about some interesting use cases. One thing is transcoding VOD for long tail content. So for a video that gets for a user generated piece of video that gets uploaded to YouTube and it never gets watched, and then a year later somebody comes by and wants to watch it, like, does YouTube actually transcode it? Right now they don't. So theoretically what you can do is for any kind of long tail content, only store the original version, but transcode it. But you can transcode it when the users are watching it. But that's actually something that's a little further down the line that we'll be looking into. But theoretically, there's nothing stopping us from doing VOD. And another thing that people have already tried to do is to kind of stream the VOD file as a live stream into the network, and just capturing and recording the result themselves, and then like putting it back together. Of course, when it comes to the requirement, really high, like VOD is a lot more fragmented, right? Because when you think about transcoding user-generated content for VOD is very different from like transcoding like a mezzanine file for a movie or something, and the latter requires a lot more lower level access into the transcoding settings and all of those things. So we're still thinking about those areas as well. So that's kind of the current status of VOD, which is the high level is we're not really focused on it right now, but that's something that would of course come after we get the live use case working well. In terms of SRT, we've been really paying attention, and it looks like SRT has gotten a lot of traction. So we do want to add SRT support for the ingest format, but we're probably looking at being able to do that a little later after we kind of launch the Streamflow test network and making sure that the end-to-end workflow actually works well. And then we have there are some other. I see that there are some other use cases related to OTT services. We're happy to talk about those. Always interested to kind of explore new use cases and think about how this network can be, this technology can be applied to different use cases, because we know that we have a very limited view of what's possible. And the whole point of having this type of decentralized technology is so that people can figure out, like, for their own cool use case, how this technology can be applied. Cool. Yeah, we got any other
All right.
questions in the audience?
I actually have a question. Earlier in the call, it was mentioned that the transcoder is responsible for delivering the transcoded video, but I thought it was that they just send it back to the broadcaster, and then it's the broadcaster's job to put it in front of a CDN. Is that not the case?
That's correct. As you just described, it is correct. The transcoders provide the transcoded video output rendition back to the broadcaster or the application that's using it, essentially, and then it's up to the application what they want to do with it.
Okay, so they only need enough bandwidth to send it back to one person.
Correct.
If I could add, Josh had added earlier that we offer the option for that that client to specify a shared storage area or something. Like he mentioned S3, so that would result in, after transcode, it would get uploaded to that place, and it's up to the implementer, of course, to decide how to set up the streaming. But he recommended that you can set up a CDN and have the CDN hit the shared storage, and I would also recommend that as a good flow model.
Yeah, so I think the interesting thing there is that object storage can be either supplied by the application or by the infrastructure provider, right? So this is something that's interesting. If an infrastructure provider wants to provide a service kind of to serve as the origin to the CDN of the application developer, they can do that, and that might be like a point of differentiation for their infrastructure.
All right. Thanks, everyone. I'm going to drop off now, but I appreciate everyone's time and joining. Nelson, thanks for organizing, coordinating with everyone. And we're around in the Discord, email, like@livepeer.org, eric@livepeer.org. If you need us, we'll talk to everyone soon.
Yeah,
Awesome.
yes,
Thanks,
definitely come and ping us in the Discord. Really happy to talk to people with cool ideas and interesting use cases.